Flatten binary tree to linked list. Now what you have to do is, this is what you are given, a binary tree, and you have to flatten it into this sort linked list. So I've already written the code. I'll run you through the code and then we can go through a dry run of one of the iterations. So how do you start? You start with current, you point it to root, and then you enter the while loop. So while you still have the current, you enter the while loop. You say if current has a left, so in this case current has a left, current enters, and now current is at 2. Right, now find the rightmost node of the left subtree. This is the pre-order predecessor. Right, this is how you find the pre-order predecessor. This is how we will solve it. So what you do is you take the previous pointer and you point it to current dot left. So you are pointing this previous pointer to 2. Now you will say, okay, while your previous has a right. So what did I say initially? That you go to the left subtree and you then go to its rightmost child. So that's what we are doing. We are going while previous dot right. We enter while previous has a right. So we went to the left subtree, went to this, we are at 4. So while previous has a right, what you do is you set now this previous you set the previous pointer to previous dot right. So now your previous pointer is at 4. Now you splice the current right subtree onto that predecessor. So what you do is your previous dot right will now point to your current dot right. So your previous was 4. You did set it to 4 over here, right? Previous equals to previous dot right. So 4's right will now point to current dot right. Your current was 1. So 4's right child will point to over here, this 5, right? Over here. And then you move the left subtree to the right and you clear the left pointer. So your current dot right, this was your current dot right, will now point to current dot left, which means current dot left is your 2. So your this 2 will come over here, right? 1, 2, and then your current dot left will be none, which means the 2 will be eradicated from here, and then your current will be set to cur equals to cur dot right, which means you advance it. So this is one of the iterations. So as I said, 1, 2, 1, 2, 5, 3, 4, 6, this is what your tree looks like. You start with iteration 1. Current equals to root, current equals to root, so you start over here 1. Now you are saying if your current has a left, yes, your current has a left, which is 2. You enter this if condition. Now find the rightmost child of the left subtree. So you have to find the pre-order predecessor, right? So what you do is rightmost node of the left subtree, your left subtree is 2. You say previous equals to cur dot left, right? So previous will be 2 over here. Now while your this previous has a right, so it has a right which is 4 over here. Now your previous dot right equals to cur dot right. So previous dot right, which means 4 dot right, will be equals to cur dot right. Cur's right is 5. So 4 dot right will point to 5. 4 dot right is equal to 5 over here, as we can see. And then your cur dot right will point to cur dot left. So your cur dot right was cur is 1, cur dot right, which means 1's right was 5. So 1 dot right will point now to cur dot left. Cur dot left is 2. So 1 dot right, your 1's rightmost child will be 2. So this 2 will come over here, right? That's what we are doing. And cur dot left will now be set to none because you want to flatten this. And this will result in this 1, 2, 3, 4, 5, 6. And you do it for every iteration. And then over here you're advancing it. So yeah, this is how you do it.